want to bring up here, Sam?
No, not from my end.
Okay, great. Neither from my side, but I see Greg hopefully in the crowd. He's going to be up here in a moment doing a bit of a demo of EVM. That's exciting. So we have an EVM pallet chain demo that's out now. Yeah, let's bring up Greg. And
Hey,
then we'll also get Garrett on the call. Listo. Great.
howdy.
Hey, Garrett, welcome to the call. Um, let's do this. So Sam, you have some slides prepared, and I don't want to steal your fire. So perhaps you could go through them, and we'll just comment on the side here.
Yeah, no, sounds great. Cool. Well, yeah, happy to just jump right in. Yeah, my name's Sam. I am one of the developers on SN10. Hopefully you can see my screen, but interrupt me if you cannot. But yeah, just for
It's actually not come through just yet, Sam.
okay,
So
good to know.
yeah, it's not loading. So I mean, hey, by the way, like if
Try.
you're doing slides, I have those slides. I can literally just take screenshots of them and send them onto the screen. I can just put them into the chat. People can look at them if it doesn't work. But you should have permissions to share your screen. Let me just see.
Cool. Yeah, I just retried it.
One more time. Maybe give it a go, Sam. Try to leave and come back on. Just and then we. Oh, you guys
It
can
looks
see
like
it. Okay,
people
well,
in the
it's
chat can
just
see it.
okay. Well, just
Okay,
Crimbo.
cool.
I don't think. Yeah, I don't. No, I don't think. I think Crimbo's just wrong.
Oh. That's so weird. So half people can see it, half can't. Yeah, really weird. If you go to uh so yeah, if you guys also like you can also just follow along there. If you can't see it, yeah, maybe we can just do that.
Yeah, that's great. Someone just chuck them in. That's fine by me.
Cool. Yeah, really weird. Okay, well, cool. Anyway, my name is Sam. I'm one of the developers on SN10. Yeah, and so today I'm just going to talk a little bit about who we are, what we're building, the problem we're solving, and where we're going from here. To kick things off, a little bit about me. My background is in cryptography and AI research, so very applicable to bittensor. Originally studying ML operations over encrypted data using fully homomorphic encryption. I was at Stanford studying CS in 2021. COVID hits. Wasn't having such a great time with everything going remote, and so I took a leave and started Sturdy right around then. Initially, we were sort of like generic DeFi lending protocol, but fast forward 2 years later, late 2023, RV2. And with it, the introduction of a primitive that was already very common in DeFi and still is called aggregators. And a very quick overview for folks who maybe are coming at this not so familiar with DeFi. Aggregators are vaults that users deposit to, which in turn distribute those assets to pools that earn yield. So if you are following along in the presentation, which you can find in the SN10 Discord, you'll see on the second slide we have this very simple aggregator diagram. The way this might work is users who have, let's say, USDC will deposit it to this aggregator. And the aggregator, let's say, has $10 million in USDC from users and will distribute it amongst 5 different pools. And what could a pool be? A pool could be a lending pool that users will borrow from, for example. So they'll borrow USDC from this pool and pay some interest rate. It could be a staking contract that emits tokens. It could be a DEX LP pool, but essentially these are all pools that earn yield, and the user here is earning interest on their USDC. So that's sort of the primitive that we're dealing with. And I think a very natural question that you might ask is, how does an aggregator determine the amount of assets that goes to each pool. So as an example, if you have like $10 million in USDC and 5 different pools that the aggregator can distribute it across, how do you decide how much that goes to each? And to give you a sense of the parameter space, each pool will generally have its own interest rate curve. So that might say that if you deposit $1 million to this pool, it will immediately yield 5%. But if you deposit 10 million, it will yield 1%. And so there's sort of these different curves that you have to consider. And then also historical data. So maybe if you deposit immediately to it, it will drop to 5%. But you know that historically, if deposits have exceeded a certain dollar amount, that maybe you've observed that the rates have dropped. And so, you can imagine all kinds of relevant data that you can extract based on the performance of this aggregator and the yield it's produced. And so you would say, okay, how much should you deposit to each pool to maximize the total yield over, let's call it a 7-day period, but this could be an hour, a day, a month, really depends. So this was the
Yeah.
problem, right? Yeah, sorry, jump in.
Yeah, can I ask, yeah, to get into more detail of how these pools work? So, um, is there like a standard contract for a pool on Ethereum that we're talking about here, or is it on Solana? Like, which chains are you mostly talking about?
Yeah, so in theory, any of them, for what we've done to date, mostly Ethereum and mostly lending pools. So the main archetype here are pools that users would deposit, the aggregator would deposit USDC to. Then other users are coming along and saying, okay, I want to put down my ETH as collateral and borrow this USDC, and I'm going to pay you a certain interest rate to do so.
And this is like a standard contract. Like if I wanted to go create a lending pool, it's almost like a Uniswap contract at this point. It's a very standard design.
Yeah, I'd say there's a little bit more variation among lending pools than there are DEXs like Uniswap. But the interest rate curves, which are sort of the most important element for our purposes, are very similar. So Aave and Compound and Morpho are like sort of the 3 largest lending projects by TVL, and they all more or less have the same curves. And by
And so
interest rate curve, I mean the trade-off between utilization, so the percent of funds deposited that are borrowed, and the interest rate.
so if more funds are being borrowed from the pool, then the interest rate would go up.
Yes, exactly. Because the goal
And
of yeah, sorry, go ahead.
oh no, no, it's fine.
Yeah, I was just going to say, and the idea there is that you want to encourage a healthy amount of liquidity in the pool, and so naturally, if more is being borrowed, rate should be higher to encourage deposits, and if utilization rates are lower, meaning less is being borrowed, you want lower rates to encourage more borrowing.
And so, this might be a question that really shows my ignorance of lending protocols on Ethereum. But if I borrow USDC from a pool with my Ethereum collateral, am I depositing more ETH into the pool than I am extracting in terms of USDC, or is it the other way around? Am I pulling out more USDC than the Ethereum collateral in dollar terms?
Yeah, no, great question. You're always over collateralizing the position. So more collateral than borrows. So that way, if the price of ETH goes down and all of a sudden it risks being under collateralized, the protocol will automatically liquidate it to prevent lenders from losing their funds.
And so like the is this the purpose for most people here is what? So if you have an over collateralized, if you're borrowing and you're pulling out less USDC than you put it into Ethereum, you're not actually exponentiating or increasing the amount of capital that you have available. You're just basically taking your hard assets that you don't want to sell, Ethereum, and getting something that's liquid.
Yeah, exactly. So liquidity is one big one. Another is leverage. So let's say you own ETH, but you're super bullish on it and you want more of it. You might deposit ETH to a lending protocol, withdraw USDC, swap that USDC for ETH. You can lever up even further by redepositing that ETH into the lending protocol. But either way, you've now wound up with a leveraged ETH position without having to use like Binance or a centralized exchange.
Interesting. So it allows you to do effectively futures of various types. So you can leverage. You can do leverage longs on Ethereum.
Yep. Yeah, exactly.
And and so in Sturdy, there's this question. If I understand the slides right, so you have all of these different pools that they have, a base token and often USDC, and they all provide some sort of curve associated with that pool. Um, wouldn't there just be one pool that's basically almost always optimal or the best at any given time that has just the lowest interest rate? And why would you ever pick any other pool? Aside from, I guess you were saying that it depends on how much you put into one pool, it might change the mathematics. Is that correct?
Yeah, so great question. This is, yeah, we talk about it a lot in one of the other slides, but I think it's a very natural question. And we've tried that basically, and the issue is that it works great for 5 minutes or an hour or sometimes 2 hours, but very quickly a lot of borrowers come along and it will sort of skew things, right? So if you put it all in the highest yielding pool, one, what will happen is that pool's interest rate will immediately drop, and then the other ones will go up because now they have less assets, and so the utilization rate has increased. So already you've introduced a lot of suboptimality. But then the second thing that will happen is then, over the course of hours and days, borrowers will naturally tend to arb those out. So they'll kind of flee from the higher interest rate pools and go towards the lower ones. And now all of a sudden you're stuck in the worst pool. So the worst can very quickly become the best. And so if you're looking to optimize over a multiple day period, which you might be on Ethereum because gas is expensive, so a single rebalance can be $100+. This is a very bad outcome if your allocation performs very well for 2 hours, but then poorly over 3 days.
And so does that mean that if you're doing optimal distribution of your funds, you'd want to look at like the elasticity of the pool size, right? Because that would
Yes.
affect. And like, is this market so totally global in the sense that it's somebody can see all of the pools very easily on a platform like Morpho, and because it almost feels like you'd want to find a pool that is hidden that nobody knows about that is somehow providing this yield. Am I right there? Like, is that an aspect of this market?
Yeah, it can be. It's sort of finding those edge cases. I think the main issue there is that very rarely can those pools handle a lot of size. So you might have a pool that only has 100,000 in deposits, and if is yielding really, insane, 1,000% APR. And if you deposit a small amount to it, it's still doing well. But as soon as you put in larger amounts, the rate plummets. And so I think that's, yeah, maybe for very small aggregators, that's useful. But I think when you're talking about millions of dollars or tens of millions, certainly it is less of a factor.
Why why does there need to be more than one pool? And like, why do people create their own?
Yeah, well, so there are lots of different yield aggregator applications that are all competing with each other. Essentially, is the answer. So Urine and Morpho, I've listed here, are two big ones, but there are dozens, if not hundreds, of these at this point, that all want to make money. They're all their sort of separate businesses, and then even within a platform like Morpho or Urine, they might have dozens of vaults for a given asset. And this is also in one of the slides, but Morpho has like 10 different USDC vaults. They're all managed by different people, and they all have different risk levels and collateral assets that you're exposed to. Yeah, and so there's just, just like there are so many like bond funds, right? Which I think is a very natural analog. Even though theoretically they're doing similar things, there's a lot of competition for money and for optimization.
And so are some of these, you said that they're managed, and like what goes into managing a pool? Like, what are people doing? Like they're adding liquidity, they're taking liquidity away, they're asking for certain types of assets. I suppose that they're providing USDT, at least on one side, to create the pool, correct?
Yeah, so I mean, I guess there's at the pool level, basically what you're describing, you can lend USDC to provide liquidity. And so I guess returning to the aggregators, that's what they're doing. The aggregators are depositing liquidity into these pools. Then there's the aggregator manager, and that's sort of the main focus of SN10, which is sort of having this meta problem of, okay, across pools, how much are you allocating to each?
And as the aggregator is the one that is submitting the USDT into these pools, um, and is effectively exchanging it for these other less liquid, more volatile assets, extremely volatile assets. Does that mean that the aggregator like Morpho is taking a lot of risk on behalf of its USDT by holding the stable token that is being pulled out? Like, I guess maybe another way to frame this would be, can I use these pools to manage risk?
Yeah, so I guess to be clear, the aggregator, the asset that there is denominated in, so like USDC, does not get swapped. So there's users who are like borrowing from these pools, but the aggregator is just supplying the liquidity, the USDC that's borrowed, and that is secured by the collateral that the borrower provides, but it's never if you're depositing USDC to an aggregator, your risk is really just denominated in USDC. You don't have like ETH price exposure since you have a liquidation mechanism that protects you from downfall. Basically, if like the price of ETH falls, the ETH in the pool gets swapped to USDC, and then that would sort of bubble up back to the aggregator. So that like the asset risk is should not exist basically for well-designed pools.
But on the other side, people that are depositing the ETH, I suppose, are taking risk because they're on
Yes.
risk with the collateral, and so they can actually lose their principal in this trade.
Correct. But that's like separate from the aggregator. But
Yeah.
yeah, you're
Okay.
totally right.
That's on the flip side. But and does that mean also that you can use these? I'm kind of segueing back to the sturdy subnet here. But does it mean that this allocation problem that inside of the aggregator space and the liquidity pool space is questions about how you can allocate resources, assets, and which assets in a way to hedge bets and de-risk yourself?
Yeah, so that's a huge part of it. Is the risk aspect, and then a big part I think is the yields as well. And so you're exactly right. And the thing that we learned as we were studying this problem is that today it's done entirely by humans. So oftentimes you'll have a handful of people who aren't asset managers by trade; they're usually developers. They'll come together once or twice a week and make these decisions manually. So they'll say, we'll put 2 million in pool A, 3 million in pool B, and kind of eyeball it. I think the issues with this are somewhat obvious, but it's suboptimal. If you have human beings doing this on a weekly or biweekly basis, who this isn't their expertise, that's not really serving their users in the best way possible. And then it also introduces an immense amount of centralization risk because you can imagine, and unfortunately this happens all too often, they might intentionally or unintentionally put it in a really bad pool with that, rug pulls or is a honeypot. And so unfortunately that happens all the time. There was just a $50 million hack of Radiant because one of the like developer keys got leaked or something.
Yeah.
And then the third is it's just, operational overhead, right? Like if you're a developer, now you suddenly have to spend a couple hours of your week on this asset management task that you're probably not that excited about.
When in this allocation problem, where you're distributing the inputs to this problem are the assets you already hold.
Yeah, so in terms of like the parameters, and actually we can uh, jump ahead a little bit. Um, the parameters that miners get are the aggregator, the asset that it's nominated in, so usually USDC or ETH, and then the pools that it can distribute to. So each aggregator will have whitelisted pools that it's allowed to deposit to, and then various historical data about that pool, its interest rate curve, and this is sort of what lets miners, perform their decision making.
So it's USDC that is being distributed by the aggregator.
Yeah, I mean, I've been using that as an example, but in theory, it can be any asset. So we have aggregators that are live today for lots of different tokens.
Right. And that makes sense. And so why not include the other side of this problem? You have a basket of goods, you want to distribute them across different pools. Is that problem effectively the same? It's just like it's the same problem as just using one asset but multiplied by 5 or whatever number of tokens you have.
Yeah, so do you mean for like the borrowing side?
Well, the deposit of the assets into these pools, right? This is the core problem that you're solving here. Correct, Sam.
Mhm.
Hopefully I'm following along. And it's always USDT or USDC or some stable coin.
Not
But it doesn't
necessarily. It can
not
be another
necessarily.
asset.
Okay. Okay. Great. Yeah, well, that's the end of my questions on that. I understand this. So let me continue with your slides here, Sam.
Awesome. Yeah. Well, no, I appreciate the questions because I'm sure a lot of people had the same ones. Um, but yeah, so I guess to sort of zoom back in, uh, we learned huge problem. $2 billion are locked in these yield aggregator applications. Uh, no one's really doing it in a way that's scalable. And we want to do it at Sturdy, but we also want to solve this problem in general so that we could release a product other people like Yearn and Morpho and all of these giants would use. Um, and we tried a couple different things. We tried to make this on-chain marketplace, but the gas was too expensive. And then we tried to use a zero knowledge approach, but the tech wasn't really there yet for a production use case. And then we came across bittensor. This is late 2023. And we realized that this was just a sort of perfect subnet because what we wanted was a crowdsourced allocation engine that had a natural built-in incentive for users to make their allocations better. And so that's exactly what we built. And so I already went over this a little bit, but the broad sort of SN10 flow is that aggregators like Sturdy and others send organic requests to validators. And a request might say something like, I have $10 million in USDC. Here's the 5 pools I want it distributed across. Give me back what I should do. What's the best allocation? Validators take this, they give it to all of the miners who ingest that data about the historical information, the current rates, the curves, come out with an allocation that's, of the 10 million, you should put 2 million in pool A, 4 million to B, and so on. Validators use some custom logic that I'll talk about in a little bit to score each of those allocations. And then they say, here's the highest scoring one and deliver it back to the application. In terms of the form factor, this can be done either via an API or entirely on chain. If you check out our Discord repo, which I put in the SN10 channel, you'll see the wrapper allocation repo, I think it's called, which actually wraps the whole flow in a smart contract. So you don't need any sort of intermediary. And we do this through API 3 or Chainlink. To dig a little bit more into how SN10 works, in particular, there are 2 kinds of requests. There's the kind I talked about just now, which are organic. They come from actual applications that have funds that they want to move on chain. And then there's synthetic. The reason why you can't just have organic requests is that they're too sparse. You might have an aggregator that only makes a request once every day or every couple days. And so in order to keep miners on their toes and make sure that you're evaluating them properly, we have synthetic requests, which use randomly generated data that's supposed to mimic those of real requests. And then I mentioned earlier that the allocations are each scored by miners. So our subnet is model agnostic. Miners can bring their own algorithms, but the scoring happens at the level of the allocations themselves. And there are a couple of factors we use. One is speed, because some allocations or some applications need very quick scoring. The other is the yield produced at t equals 0. And this was, Const asked the question, okay, well, maybe you should just stop here, right? Like this is all you need. But I think we sort of explained that this is insufficient because you might have an allocation that does really well immediately, but very poorly over a 7-day period. And we found that this is actually quite common. So to supplement this, we have simulations that the validators run based on parameters we supply that are designed to mimic real borrower behavior and this kind of natural demand supply dynamics that I went over earlier, so that we can say, okay, here's what the allocation will most likely look like an hour or a week from now, depending on what the application specifies as part of their request. The other metric that we're introducing soon that we're really excited about is actually looking at the real yield. And this would just be for organic requests, where we could say, here's the allocation that you gave us, here's how it actually performed after 24 hours, and now we're going to score you based on that. And then the final factor in the scoring is plagiarism detection. So this is designed to deter relay mining or miners that just copy other miners. Basically, if you submit allocations that are too similar to those of other miners, you'll get penalized. And so we encourage a little bit of original development here.
So, Sam, let's go down to the raw problem definition that a miner would be solving. So they're given the state space, which is the pools that they're allowed to allocate into. How many pools are we talking? Like 10, 20, 10,000, 5,000, 6?
Usually 5 to 10.
Usually 5 to 10. So and then they're given an amount that they're about to allocate, they're supposed to allocate, and that I suppose in the synthetic domain is just a random number that you generate that's a value between 0 and 5 to 10 million or something.
Yep.
And so they're given this as input. The miners are given this as input, and they go and look at the aggregator. They look at these pools, and what
and its parameters allow them to say at t equals 0, if I deposit this much to this pool, it will produce this yield. Then we also give them, and this is why very recent update, miners now need alchemy keys to read directly from the chain. And what this lets them do is say, get the actual address of the pool and then get any data about it they want, right? So they can pull, there's no sort of privacy. They get to pull anything that has ever happened. So all the deposits, all the withdrawals, and all the yield that's been produced by this pool that they're able to see and use that in their models.
And what information would a miner? So I mean, first of all, the curve is parameterized by is it parameterized, or is it literally just how does one parameterize the pool? Is it the yield curve?
So for lending pools, it's by utilization rate. It's usually a pinked linear function where the slope will slowly increase and then it will increase a lot. So in particular, you might say that if the utilization rate is like 10%, meaning 10% of all the funds in the pool are being borrowed, maybe it will yield 1%. At 90% utilization, it will yield 5%. But then when you get to 95% utilization, it will yield like 25%, something like that. That's a very common structure.
Usually, it's a linear curve that's and it sounds like it's a section linear curve. It's a piecewise linear curve, and or it's even a step function. Is that a step function or a linear?
It's linear.
It's linear. Okay, it's linear. So you take the points and you interpolate between them. And so these are the parameters of the lending curve. And then you said there's also historical information. Excuse me. So what would a miner look? And this historical information has everything from like rates of trades, who traded, I guess if that might be relevant, into the pool, out of the pool, which assets were added to the pool. Is that correct? And
yeah,
I mean,
so
obviously.
If I'm a miner, the main things that I care about are the rate history and how it corresponds to deposits. So maybe if I observe that every time I make a big deposit to a pool, a borrower is there to meet that, and raise the rates subsequently, that's a pool I'd want to deposit to. Whereas I might look at another pool and say, okay, last time or last several times there was a large deposit to this pool and the utilization rate dropped. It really didn't increase for a month, right? The rate stayed pretty low, both of utilization and of interest. And so that's a pool that I'd probably want to stay away from depositing into because the rates aren't going to be so good. So that's like a piece of information that you could really only know by looking at the historical data and not at the just the raw interest rate curves.
And why would there be a pool like that that nobody digs into?
Yeah, it really depends on the collateral assets and the market conditions. So, for example, and I'll talk about this in a bit, like we work with this project called Dinero on creating demand for their asset PXETH. And so for some of the collateral assets might get like really hot for a month where everyone wants to get leverage on it. And so people would, rush into that pool for, let's say, like an airdrop or something. They want to hold this asset, get leverage on it, earn this airdrop by holding the asset. But maybe the airdrop passes, and now all of a sudden, like no one really cares about holding this asset. So then you'd expect utilization to go down, you expect interest rates to go down because no longer demand for leverage on it.
Right. So in this allocation problem is some intelligence regarding the types of assets that are in the pool and how those assets perform or whether or not they're relevant and or whether so you're looking for pools that when you deposit capital into, people are going to follow suit in some sense and increase the yield.
Yeah, exactly. So you want sustained demand for a pool. And I mean, we're getting sort of into specifics. I think the general problem we want to solve is much larger and extends beyond lending pools. But yeah, for lending pools in particular, I think that's exactly right.
And that's a temporal problem, right? Like you could only know that over time if you're making predictions about whether or not the pool is going to get more attention in the future. Is the subnet designed to ask miners to think that way, to try to find pools that will perform well at a later date?
Yes, yeah. So
Or
that's incentivized through the simulations, which kind of try to mimic the borrower behavior. But I think will be better captured by actually doing this with the real data and having this kind of staggered scoring where allocations are scored 24 hours after the fact through the real conditions.
yeah, exactly, because I don't think you'd ever be able to encapsulate that complexity in a synthetic simulating a simulator, right? So and also like even with a simulator, the obvious thing to do as a miner would just be to run that simulator. So like the specifics of your simulator are actually incredibly um important to the way in which your incentive landscape is designed, obviously, and then not necessarily in alignment with what actually would happen in reality, right? Um,
Yeah.
uh, so, but thinking like a miner, Sam, on your subnet, like how do you think or how do you know that miners are approaching this problem in unique ways? Like what techniques are being applied behind the veil here that make this subnet optimal compared to other teams?
Yeah, absolutely. So I think a lot of people have been doing something similar to what you're saying, which is backing into it through the simulations, like looking at what simulations tend to produce and sort of retrofitting around that, which can be good if your simulations are accurate, but obviously we want to make something better with a real yield um, and capturing that on chain as opposed to over relying on it. I think in terms of specific techniques, we've seen a lot. I mean, ranging from rules-based stuff, like that was our kind of initial stab at it that we deployed as a test miner, but sort of got deregged very quickly. And I think now we're seeing some more sophisticated, like proper machine learning techniques based on historical data. Still some rules-based stuff around the simulations and trying to apply like Monte Carlo or other optimization techniques to them. But I suspect as we transition to real yield scoring that you'll see much more machine learning techniques.
So what is the core problem that miners are solving when it comes to this? Like how are they approaching it, right? So they're given the parameters, the amount of input, the amount of money they're taking to allocate. They're given these liquidity pools, you say 6 to 10. They take the incentive, sorry, the interest rate curve, and do they just run 10,000 simulations, uh, right, with different parameters? Because it sounds like a knapsack problem that could be solved combinatorially, right? Do the miners just apply a combinatorial, like they pick a random allocation, they run a simulation, they use a black box optimizer or a genetic algorithm to pick the next allocation, and then they just optimize that? And how long do they have to do this optimization? Like what exactly? You said you're rewarding for speed. And my question would be, why reward for speed? Is the lending market so fast moving, and that you're imagining that users are going to be doing uh like high frequency trading amongst these pools?
Yeah,
Where
so
exactly?
they can be on other chains. They can be more fluid, and we want to have the scoring ready for that, even though the ones that we have to date aren't. The other big issue is if you're too slow, the issue that you'll tend to run, or that you can run into, is execution errors. So you'll have an aggregator that pings the subnet, but if it waits like 5 blocks, it's possible that the new allocation will fail because there will have been some deposits and withdrawals in the meantime that make the transaction revert. Because let's say it goes to remove like 10,000 USDC from pool A, but all of a sudden, because of a certain withdrawal, it can no longer do that. And so then it's really frustrating for customers because they just wasted like $100 and now they have to manually go in and redo this.
Right. So there is a temporal aspect because the trade itself can move underneath your feet very quickly. And um is that correct? Like if I'm going to put my money into these lending pools, is there significant variance in the APY I can attain within a single block time?
Usually, it's just more trying to avoid the edge case where you get a big deposit or withdrawal in the interim, which can also potentially be a way to manipulate the pool as well. And so that's one of the challenges, and we've been thinking a lot about that when it comes to the real yield scoring is, if a pool is small enough, a miner can come in and just like deposit and withdraw in a way that favors their allocation. And so, yeah, I think initially when we roll this out, it's only going to be for some of the larger pools, just to avoid that possibility.
Right. Okay. So like jumping to so I think the answer I didn't really get it, which was like what algorithms do you imagine that the miners are running? Do you have any understanding of that, Sam?
Yeah, yeah. So there are some combinatorial, like you're describing, where they're, yeah, either treating it as a form of a knapsack problem, or just like running a simulation. There are some that are using real on-chain data, like I mentioned, start requiring Alchemy APIs so that users can read from the chain, and that's free to do. Um, yeah, our goal, I think, is to push more and more users in that direction because I think it's a much better representation of the actual problem we want to solve, which is optimizing yields over a certain time period, which is subject to many variable conditions and requires, yeah, it's much more challenging than I think optimizing for the simulation, which can potentially be gamed.
Can I jump in here?
You're welcome.
Um, I just looked through the code, and the assets and pools that get sent to the miner are just based off random jump number generators right now. How can you say that your subnet is responsible for $50 million in pools if they're just running a simulation on random numbers right now?
Yeah, so there's two requests types. There's organic and synthetic. Where you're describing other synthetic requests. Yeah, maybe I glossed over this, but the reason why we have those is because organic requests are pretty sparse. Maybe they'll be daily per aggregator. Yeah, if you
Do
look,
those organic requests get scored?
yeah, yeah. We're actually going to weigh them more heavily as well, but they already get scored.
Oh, cool. And where's what's the scoring algorithm for that? Do you use the real data in the future to score it, or is that I thought you said you were transitioning towards that. So how do you score the organic now if you don't yet have the real data yet?
Yeah, right now the same as synthetic. So through yield produced at t equals 0, speed, simulated yield, plagiarism detection.
Okay, so it's the same simulated algorithm that the validator runs. In that case, can't the miner just run every possibility um, to get the best yield and then return that? And isn't that what the miners are all still doing?
I mean, you can't do like, since it's a continuous space, like you can't do all of them, but uh, yeah, in the time permitted, you could try to segment it like that, where maybe you sample a dozen or a couple dozen points and run those. And yeah, that's certainly possible. I'd be surprised if that was competitive enough at this point. Yeah, it's been pretty tight. So yeah, I think you need a pretty good level of specificity to do that, and I don't think that approach would yield it.
Yeah. No, I remember okay, no, sorry, I'll let you continue the presentation.
Cool.
Thanks, Fish.
Um,
But yeah, Sam, yeah, go on.
Awesome. Well, yeah, that sort of is the overview of SN10. I think we get into the part that I'm most excited about, which is the impact and what we're doing today. And yeah, I know we're already 45 minutes in, but we'll sort of try to go over this quickly. Right now, we have 7 aggregators managed by SN10 that have cumulatively allocated $60 million across all of our rebalances. Um, and yeah, you can see this graph on the right that shows SN10 in gray, DAI DSR, called the DAI savings rate in green, Aave USDC lending rate in blue, DAI and Aave, these are like the two of the largest DeFi projects. And then the gray is the average that SN10 has produced. You can see that it was like SN10 was doing kind of comically well up until August, and this is because our deposits were really small. I think we had like $1 million total allocated up until August 2024, and so maybe 2 million to September, but then really most of the growth has come over the past month. And so while it's quite a bit more competitive now between SN10 and DAI and Aave, we still have a pretty good edge, which I've been really happy to see. And yeah, this is all on the dashboard, by the way, that I linked in our subnet channel.
And
I think to
and
give. Mhm.
Sam, so at the beginning, the original numbers that you said were comical, right? 100% APY. It came from allocating such a small amount, doesn't change the pools enough to change the APYs, and you can take advantage of like moving low amounts of liquidity. Um, how do we know that that has been removed or is no longer an artifact today, right? October rather than March.
Yeah, I mean, you could argue that it's easier to allocate tens of millions than like the hundreds of millions that DAI or Aave have. I think if you look at the pools are now at like critical mass and awareness, then I think that's unlikely. The main reason why really small pools do well is that people just don't know about them, and there's like a huge information asymmetry. But at this point, like when we're talking about millions or tens of millions, I don't think that exists to the same degree. But yeah, we'll have to see. I mean, our goal is to hit 100 million by the end of the year, and maybe if we get that, it will go down. So I guess we'll have to see. But yeah, so far I'm pretty confident that SN10 will continue to outperform.
So, just so I understand what you're saying with these numbers, people are using SN10 and allocating currently about $50 million
Right.
on a day-to-day basis. It's changing hands. It's going into different pools, and they're using this backend to do this allocation. That's happening automatically or semi-automatically. They're calling the API, the API. They're talking to the network.
Yes,
Correct.
so most of our customers have it set up so that will happen automatically every couple days, depending on their cadence. They're all on mainnet right now, so that's not that frequent. It's usually every couple days. We're going to have some more chains on board soon that will let us speed it up a ton. Gas costs a cent. All of a sudden, you can do some much more interesting things and rebalance all the time.
And how are you measuring this performance? Like when it comes down, I mean, I suppose you have a history of allocations, right? And so you're just doing a back test on the APY that they attained. Is that how you get this aggregate?
Yeah, so for the graph here, that's just taking the APY at any given time. I don't know how frequently it's measured. I guess at least a couple times per day, but yeah, I'd have to check on that. And then yeah, averaging it across all of our aggregators managed by SN10, and then plotting it here. Um,
So
yeah,
does that
to
mean
get
that I
the
can?
composite.
Does that mean that I could take a look at the total basket of goods that have been allocated or currently allocated by um, SN10? Is there like a stateful nature there that we could evaluate and even copy? Like I could go and find that allocation and copy that allocation.
Yeah, absolutely. This is all on chain and on our dashboard. I don't have it in front of me right now, but there is a section where you can see the actual allocations, which I think is super cool. So you can see here's the miner that submitted the allocation, and then here's the Etherscan transaction where it actually got implemented. So I think that's cool. I mean, as you know, a former miner, to be able to see like your work have a real impact on millions of dollars in funds on chain. Um, and yeah, I talk about this later in the presentation, but we're sort of hoping to streamline that so that you can see all the aggregators, deposit, withdraw from them, view your positions, look at the rebalances in one place. Because right now it's a little bit scattered.
So right now, you guys are just about doing double what um, these other aggregators are achieving. Aave is like the so you were for this chart. If you forgive me, the blue line is Aave,
Yes.
and so they're allocating more than 50 million. They're allocating
Yeah.
maybe billions of dollars. How many billions of dollars are they allocating?
Uh, uh, so yeah, these are lending pool products. And DSR is sort of like a staking contract, but these are sort of used as the two baselines. I mean, it's almost like the treasury type benchmark. In terms of the amount, I have to check. They're each though like 1 to 5 billion.
And so, do we think that we would be able to attain that same APY increase if we were allocating as much as them reasonably?
Yeah, I don't know.
Probably
I mean, by
not.
the time you get to that size, probably not. I think the other thing that they have going for them is that they're perceived as less risky. So it's, the users are willing to accept a lower APR in exchange for that. Uh, One of the cool things that we have coming up is an integration into a project that has a number of vaults, and we will be essentially SN10 will be owning the allocation process for some of them, but not others. And I think that will be a really perfect benchmark because it's kind of the best apples to apples comparison you can get since it's the same uh, project, same asset. It will be a similar basket of pools that they're each distributing to, but one will use humans, one will use SN10, and I think at that point, we'll have something that is really the most one-to-one that you can get.
Is your APY in the slide that says SN10 by the numbers calculated by actual APY of the pools some amount of time later? Or is it the predicted APY
No,
by
this
this
is
function I
actual
see?
APY.
Oh, cool. How far after the fact do you calculate APY for this graph?
Yeah, so it's just looking at the actual APR of the pool at a given time. So it's not even like considering when the allocations are made, the predictions, anything. It's just saying, okay, SN10's managing in this aggregator. It's yielding like 5% right now. I'm going to mark that in the book. Come back in an hour, mark the next one, and so on.
Oh wow, that's amazing. And so you're at 20%. Is that realistically sustainable?
Yeah, and I mean, this is what we were talking about before. We'll see, I guess is the answer. I think probably not as we scale. I'd be surprised if it stayed that high. Um, But yeah, I think our goal is really just to outperform what a human would do, since that's ultimately what our customers and their end users care about.
Cool. Sam, we're moving so slow because we're just probing you with many questions. But let's jump to. I know you have some more slides here and also some reveals, and let's get to those.
For sure, yeah, I'll skip around a little bit. Today, and this is also linked in our Discord, we announced a new aggregator. It's not live yet. It should be probably late next week or early the next one with Morpho. These guys are giant, $2 billion in deposits. They have a ton of different USDC vaults, and we're working with them to make it easier for users to manage all of that. So instead of having to pick between the 10, we're just going to have one product managed by SN10 that will do everything for them and allocate among them. So we're super excited about that. We're also using to build this vault an infrastructure provider called Era. If you know the team at Gauntlet, they're sort of legendary among in DeFi for risk management. They built this tool, so we're really really excited about this. Should be live next week. Yeah, I don't have too much to say about that, but you can check out the announcement in our Discord. And so yeah, what's next for SN10? What are we up to? To maybe skip around a little bit, I think one thing is more optimization types. So there's this aggregator problem that we're solving, but you can really apply this to a lot of optimization within DeFi. One thing I get asked about all the time is, is there a play here with DTAO? And that's something we're thinking about. And if there's a way to do it that's value additive to the ecosystem and not extractive. The other thing you can look forward to is more third-party integration. So just like Morpho, Gauntlet, I think we have a bunch of others that will be really exciting and bring more eyes to bittensor and SN10. So we're excited about that. Improved scoring, I think we've touched on it a bunch of times, but using real-world data, obviously better than simulated data. So that will make our yields better, it'll make our allocations better, it'll let us better serve our customers. And then finally, improving our dashboard. Right now, I think it needs a lot of work, and that's coming very soon. The first thing that I'm really excited about, and we're almost done here, is a single place where you can find and interact with every SN10 aggregator in a single place. One of the downsides of having so many people now building on top of SN10 is that, people ask, well, how can I take advantage of this? How can I deposit to an aggregator controlled by SN10? I have to send them like 10 different pages and each have their own instructions, and it's a little bit confusing, especially if you're not super familiar with DeFi. So we want to consolidate this, get it all in one place, make it really easy to see how's SN10 doing, how are the APRs, how's the TVL, one screen. This is just a mock-up, but this is how it will look like. The other final thing I want to touch on is a way to actually create aggregators through a UI. So right now, it's kind of hard to create an aggregator in general, really hard to make it integrated into SN10. It's sort of like you have to come to us, the developer team, we do it for you. Not a great user experience. Maybe it works for 2 or 3 customers, but we want dozens with billions of dollars in TVL. It's not going to scale. We have this mock-up UI that this will probably take a month. I think the other one should be ready next week, but yeah, this will be a month or 2 at least. But anyway, users will be able to just come here, say, hey, I want to make the bittensor aggregator, whatever, for like WTAO, right? Or like some TAO on EVM. I can come here, put that in, select the different pools I want, give the requisite historical data, and I'll be good to go. I don't need any developer experience besides, maybe creating some of the APIs. But yeah, we're super excited about this. I think the goal is for all of SN10, from deposits, withdrawals, creating aggregators, to be managed through a single UI that is transparent, verifiable, open source, and yeah, hopefully draw a lot more attention to bittensor and showcase exactly what is possible through it.
Thank you, Sam. One last question. Looking at the incentive landscape for SN10, like almost every single miner here is almost exactly at the same value of 0.0044. Do you see that as an issue of incentive design, or or do you know why the curve is so flat? Because something like this is very difficult and dangerous for bittensor in general, because with such a low diversity in incentive, or a variance in the incentive, it's very easy to apply effectively a UMA attack. So any validator on the subnet can just privilege all of their own miners, and there's no way of determining the truth of the matter because there's not enough variance. So I think that, one of the things I perhaps would suggest that you look at is why that is so flat, and why the miners are all attaining the same score, because it does open up a direct UMA attack on the subnet.
Yeah, that's something that we worked on for a while and improved quite a bit. We came out with a new update 2 days ago that ended up doing what you're describing. It flattened the curve a bunch. Yeah, what we're monitoring now is whether that's just a temporary thing, because we paused and unpaused registrations for a while, and so, to let validators update. So maybe that had an effect. But yeah, it's something we're monitoring, because I definitely hear what you're saying, and that's not something we want long term. So yeah, I think if it's still an issue, we'll probably make some tweaks, but I think the longer term solution to that is just using data, because that is much harder to game, and yeah, it will also just help us serve our customers better.
Yeah, absolutely. Where do you want to take 7 to 10 from here? Like, where's the pie in the sky? So, like, right now you're doing allocations. Is the plan to build more of a risk management design subnet company? Where does it go, Sam? Like, how do we optimize it and go farther and take this to the sky?
Yeah, absolutely. I think we want initially every DeFi project with some sort of optimization component, whether that be for yield, for trading, um, to tap into SN10, and for SN10 to be the backbone of that, and to be able to do so permissionlessly without needing to come to us and creating a bespoke integration. I mean, that's sort of the intermediate goal, but beyond that, this doesn't have to be limited to crypto. Like, you could think about applying this to any market with any sort of optimization, whether that be bonds or equities. You can sort of imagine this being applicable in all sorts of places. So that's really where we want to get to eventually, is have such a strong base of miners and data that we're able to apply any, tackle basically any sort of financialized optimization problem.
Very cool. Sam, thanks. Thank you so much for coming up on the stage and showcasing this, man. Nobody saw the slides, but we pushed them into the
Oh no.
channel
Okay.
here. Well, some people saw them in the chat, and also from you
Okay.
in subnet 10. So you can take a look at the slides at length. But in awareness of the time here, we also wanted to jump into talking about EVM. And Greg is going to do a bit of a demo for us. Hopefully your screen works here, Greg.
Yeah,
for this demo.
let's try. That was really cool presentation of SN10 things. How cool would be to create aggregators right on the subtensor network. I'm gonna try to yeah, okay. Can you see it?
Not yet. No, you just closed it off.
Oof. Let me try again.
Try. It was a nice segue. I'll give that to you, Greg.
Aha.
We can see. At least
All right. Yep. I'll I'll start with this beautiful documentation that we have. Thank you, Raj, for putting this together so quickly. This is our EVM tutorial. It tells about really basic things about EVM. You won't, if you read this, you won't become a Web3 engineer, but for people new to Ethereum or EVM, this would be really helpful. And I'll start right here, EVM with MetaMask, testnet with MetaMask, because we have a faucet page here. So let's see what we can do here. So like I said, it works with MetaMask. Here's my MetaMask, and here is it's connected to bittensor network. It's EVM testnet. that we're running for a while. And I have here some small balance. Let's request some tau, some test tau from our faucet. See, it's it's priceless. Okay, it doesn't work. Anyway, demos.
Demos.
I knew it's not. I'm gonna have problem, but that's why I have some balance on this.
Look at that. Look at that tau in MetaMask. That looks nice.
That's
Fire.
tau. Yeah, that could be real tau. And I have another account. Let me see. Let me just transfer some. I'm pretty sure this is gonna work. I'm gonna transfer. All right, about half tau to my other account and see what happens. So I have the window here opened. Let me see. I need another window like that so that I don't lose my state display. This is Polkadot Apps UI. This is connecting to Substrate interface, and I think I was too late to open it. But if I click a few blocks back, I see the balance transfer happened. It's in Ethereum transaction, and let's see how my balances look now. This balance decreased, and the balance on this account increased. I had 0.36. Now I have 0.86. So that works. That's great. It works, but it's not very exciting because well, we have so many Ethereum chains. Or even scaling solutions or rollups, whatever. All of them just don't do much more than just scale in Ethereum. What we can do here is we can connect this EVM machine through precompiles to bittensor functions. And one of these features is staking. I don't need this guy. I need this documentation. Yeah. So one of these features is staking. We can stake with a precompile and give. If I look at the stake, we can. Here's my hot and cold key. I can increase the stake using my MetaMask interface. Let's see how this happens. This document actually guides me through this. And here is my staking precompile ABI. If somebody doesn't know what ABI is, this document explains it, but I can really quickly explain. It's an interface that describes how to interact with smart contracts. I'm going to use this environment. It's called Remix. This is integrated development environment for Ethereum smart contracts. But I can connect it to any other network, and like for example, I'm going to connect it to my MetaMask, which is connected to Subtensor network, which means my Remix is going to be connected to Subtensor EVM testnet. That's my account that I'm going to use, and a really simple way to interact with the contract. I can copy and paste. I already did this before. I can copy and paste my ABI into Remix IDE editor, and then I can say this is the contract that I want to interact with at this address, which means it will create a smart contract and create this nice UI interface for me to interact with this smart contract precompile. Here I need a hotkey, and I need I need some tau to send. So I already have my tau here. It's 0.86. I'm going to transfer. Let's say I'm going to transfer half tau, which is 5 and 17 zeros. It's how we encode native currency in EVM. It's always 18 decimals. And I need a hotkey. This is a public key for the hotkey that I'm going to stake to. Because this testnet already has a Fini state as of a couple of weeks ago. So we have Open Tensor Foundation hotkey on it. So that's the hotkey. And in order to convert it to this format, bytes 32, I need to extract public key of it. It's done through ss58.org. I'm going to just decode the substrate address, and it's going to give me a public key. Here's the public key. It's 32 bytes. and I'm copying it here. So now if everything is ready to run this transaction, so let's see what happens. Just before I run it, here is my cold key address. I'm going to explain in a moment how I converted my MetaMask address into this guy. So these are two same addresses actually. And I see in apps UI, I see this, it has approximately 1.1 tau stake to OTF hotkey. Let's run the transaction and see what happens. I still don't know if it's going to work. Looks like it worked. And I'm going to, let's switch right here and maybe here. I'm going to see if I ran. Yeah, it ran. I see the stake was added. Here's my cold key, and Ethereum transaction executed successfully. Let's see what happens here. You see, I have 1.6 tau stake now. I didn't even touch BTC or none of the SS58 address private keys. I completely operated through MetaMask. So the idea here is to provide this functionality to and open this functionality to smart contracts, to Ethereum smart contracts. We will be able very soon to stake, unstake, and do all kinds of things with this smart contracts. Everything that flexibility of smart contracts allows us to do, like staking pools or maybe liquid staking and whatnot.
As well as cross-chain bridging, and potentially even liquidity pools on top of Sturdy.
Yes,
I can
yes.
its interaction with dynamic tau will be something else to see. Very interesting.
Oh yeah, yeah.
There's, we wondered for a while if we should have EVM compatibility, and like it opens up some Pandora's boxes. We imagine that there'll be some really interesting DeFi and potentially annoying DeFi things that happen on the chain, but I think leaning into this idea that we should have more freedom on the bittensor network, as just a matter of principle, and ripping the band-aid off and going towards allowing people to build novel applications and add liquidity across the ecosystem could only be positive for people, right? So we probably will see all sorts of interesting things occur, right? Staking across different validators, and depending on APY of those validators and subnets, the direct allocation of child keys, the quick allocation of child keys. We're going to add a lot more liquidity and movement into bittensor from this pallet that we will have to monitor closely. But I think in the end, the steady state will be something that's very positive for bittensor. On top of that, like I know that a number of subnets that are already thinking about ways of actually directly monetizing the commodities, and do transactional flow through their subnets, so that we can actually integrate, direct transaction for, say, an inference request on something like subnet 4 or 19. You could build that with a smart contract in a way that you can't do on bittensor as it is built today, which is really interesting. And we might see a whole market of different digital commodities being traded on bittensor now that we have this pool available to people to use. And that might drive, if everything is again like measured using the foundational unit of tau, and we are paying for gas, we can even drive demand for tau, aside from the regular demand to have ownership of subnets, just through the need for gas, which is more of a common primitive in the entire space. So it's very interesting, Greg. Like you're unleashing a beast. It's very exciting. Well done. Number one, I really hope that this allows for cross-chain bridging for the first time on bittensor in a really trustless way. But also, I'm really looking forward to seeing what other people build and have fun with over the next little while.
Thank you.
Thank you, Greg. And are there any questions from the audience for Sturdy, for Greg, for myself, for Fish, for Garrett, anyone on the stage? Does anyone want to come on the stage and ask questions to any of those participants? Now's the time. Just let me know. Put your hand up and you can jump on. Perhaps, Greg, you want to explain how to use the EVM palette, where it is. Like, it's not on mainnet today, but it is available to use on the EVM testnet.
Yeah. Okay.
you-
Yes. Yes. Exactly. It's not on mainnet yet. It's on its own dedicated testnet, which we refer to in documentation. So the documents will go guide you through how to connect to this, whether you need to whether you're a developer or just a user to want to try it. It explains how to connect MetaMask or how to configure Hardhat, for example. So it's going to stay in this state for a while. Maybe we'll deploy it to the testnet to the larger testnet fairly soon. But I think, yeah, Raj just posted this comment in the chat, so you can open the documents and see how to interact with this palette. But generally, yes, generally it's just EVM in Frontier palettes but we had to fork them to handle the decimals correctly and just generally improve the security of Frontier. But they are not much different from what, for example, Moonbeam does based on Substrate or some other networks that already used the Frontier and EVM palettes.
I have a question about the Frontier implementation. Actually, the Frontier is not supported anymore officially. So, is there any plan to maintain current Frontier implementation to follow the Ethereum Yellow white paper? Because recently Ethereum trying to improve several proposals, trying to improve several protocol right now, but looks like the Frontier is outdated to follow them. Is there any plan? Yeah,
it's always been outdated, but I see Parity, at least the fork that Parity supports, it's been updated. Like we have, it was Keith from Nucleus team who made a PR to update it to Polkadot 1.16, but it's been on Polkadot 1.11 just before that, so it was not outdated for too long. Also, some other community projects support maintain Frontier, so we're not alone here if we decide to. But we will certainly have to maintain it for at least a while until they maybe accept our changes upstream, whoever they are. But for now, yes, we approaching this with a mixed approach. This is kind of a mixed approach. We'll be both maintaining our fork and maybe looking at how the other forks are supported and maintained.
Okay, great. So I'd love to hear about the next step of the Frontier implementation. For example, the account abstraction, because the account abstraction is so crucial part for DeFi protocols and onboard so many ERC20 tokens to the EVM palette. Is there any plan to implement them also?
Are you talking about some particular EIPs or?
Yeah. Account abstraction.
Not at this moment, but so to be honest, we haven't planned that far away yet. Frontier, well, yeah, that's a common problem for the whole ecosystem. We'll see where it goes, because like for example, Moonbeam will have the same issue exactly.
Okay.
So I hope this will be some kind of a joint effort, not necessarily done by every individual project who supports Frontier fork.
Okay. Thank you.
Well, thank you, Greg.
Right.
I mean, it's going to be very exciting. Thank you so much, Greg. Thank you so much, Sam. I think there's a poker game happening after this call. I'll let people jump to it. And have fun, everyone. Take care. Have a good night.
Thank you.
Ciao.
And a good call it
you, bye.
was. I think next I'm gonna go eat lunch, and then I will probably come back and see if I can prep for West Coast ML tonight, because we are doing another follow-up of Chain of Thought Decoding and Entropics. So I'm gonna see if I can like dig into that repo and actually figure it out. So maybe you'll want to watch that if you have caught the Entropics bug like some other folks have. But yeah, that is very cool. I'm super glad that we have an EVM palette implemented, janky though it may be. Welcome to Polkadot, I suppose. But I assume at one point or another we'll get the account abstraction like figured out in terms of these like EVM emulation things, or like have maybe like interchain accounts is kind of the move. I don't know. Anyway, weird crypto shit.